Okay, so we're going to work in section 5.5, and this section has quite a few theorems. So when you get ready to do your note page for the next exam, you're going to probably want to reference a lot of these theorems, okay? Because it's kind of tricky to remember all of them. They talk in the beginning about the volume of a cake. So volume is a cubic measurement. So you're going to figure out like how much water to put in a swimming pool. It's going to be so many cubic meters or cubic feet or something like that. For a cake, it'll be in inches. But they want you to understand that, these problems that we're working on, and in this section we're going to be finding zeros of a polynomial, that can be applied to something like the volume of a cake or a swimming pool or something else. Those are higher degree polynomials that we might be working with. And we'll actually do this problem about the volume of a cake in the last video for this section. Okay, so the remainder theorem. So let's say you have a polynomial, f of x, and it's some polynomial, and you want to evaluate the polynomial at a number, say f of k. The number could be 3 or -4 or something like that. Now we know how to evaluate a polynomial for a number, but we're going to learn a new technique here. Okay, so we know a volume or a polynomial can be divided by another polynomial, right? And then there's a quotient for that polynomial, oopsies, plus a remainder. And that those are all polynomials. We had that with the division algorithm. Okay, so what we're going to do is we're going to divide our polynomial by x minus k. Now remember, we're going to try to evaluate at k. I tried to make a better k there so it didn't look like an x, hopefully. We know that we can divide our polynomial by x minus k, and that it's going to be equal to some quotient that if I multiplied x minus k times q of x, and then I add in the remainder, that would equal the original polynomial. Now, some of you, if you're watching along, you're saying, hey, wait a minute, she didn't put r of x, she just put r. We know that this has to be a constant. And you might say, well, how do we know that? Because we're dividing by a linear factor, and the remainder has to be at least 1 degree less than what you're dividing by. So we know that r is just going to be a constant. Now that's going to be important to us for this next thing that we're going to do. Okay, so we're saying we want to evaluate this polynomial f of, and we want to put in k. I'll put it in a different color, maybe that will help. And we're saying that's going to equal then, if I were to write k, I'm putting it in for x, right? Times q of k plus r, that constant. Well, what's k minus k? 0. What's 0 times q of k? 0. So you get 0 plus r, or just r. So what we're saying is, if you want to evaluate a polynomial at some number, you can just divide by the factor, and whatever the remainder is, that equals the evaluation. Now, because of synthetic division, we're going to be able to do this really easily. Okay, so here comes our example. Use the remainder theorem to evaluate f of x, and here's the polynomial, right? It's kind of long, at x equals 2. So think about the factor x minus 2, and then you're going to use that to divide synthetically into your polynomial. So you have 6, -1, -15, 2, and -7. So hopefully you loved synthetic division, or you're learning to love it, because there's a lot of synthetic division in this section. Okay, so we're going to divide synthetically because it's going to be easier, and then whatever the remainder is, that will be what f of 2 equals. We are trying to find f of 2. Okay, so bring down the 6. We're reviewing synthetic division now. 6 times 2 is 12. That's an 11. 11 times 2 is 22. Negative 17 and 22 is going to be 7. 7 times 2 is 14. 14 and 2 is 16. 16 times 2 is 32. And so I think I'm going to get a 25 here. All right. So I'm going to say f of 2 equals 25. Now you might be saying, well, that's fine. I can do that, synthetic division. But why don't I just evaluate the polynomial? Okay, well, here's what that would look like. F of 2 equals 6 times 2 to the 4th minus 2 cubed minus 15 times 2 squared plus 2 times 2, minus 7. Okay, so it already probably took me longer to write it out than to do the synthetic division. 2 to the 4th is 16. I'm doing this by hand. I don't have a calculator handy. So what's 16 times 6? 96. So let's see. If I add the positive ones together, that's 100. If I add the negative ones together, I get 75. So yeah, that equals 25. But see, I think this took me longer to do than the synthetic division did. Okay, so that's the beauty of the remainder theorem. You can have a big old polynomial, and with synthetic division, you can fairly quickly evaluate it.